Hello everyone, let's look at find first and last position of element in sorted array. The problem statement is we are given an array of integers nums, sorted in ascending order. We want to find the starting and ending position of a given target value. If not found, simply return -1, -1. One follow-up challenge is, can we do that with the time complexity of O log n? Let's look at example 1. The input num is 5, 7, 7, 8, 8, 10. The target is 8. The output is 3 and 4. That's the start index and end index for this 2, 8. And for the second example, input is 5, 7, 7, 8, 10. The target is 6. 6 is not one of the elements for the input array. We simply return -1, -1. And third example, if the input, the length is 0, and we simply return -1, -1. And because of time complexity here, we should use binary search. And one solution is to run the binary search twice to determine the first position and last position. Let's look at the code. Let's try to first write down the standard binary search solution to have a basic structure. So because we have this nums length -1, let's also do a length check in the first place. This is our basic binary search. The idea is we run this piece of code twice. Obviously not exactly the same piece of code. We run this basic binary search twice to find the first and last position. However, the problem here is, in the input array, it has duplicate elements. So we need to do extra step to move our left or right pointer. Let's say we want to find the first position, that's our left boundary. The key point is how do we handle the case if target equals nums mid? Obviously, we don't want to stop the loop. We don't want to return it. We want to move extra steps. Let me say that again. We want to move extra steps. We want to make sure this mid value keep pushing to its left. The same thing is we need to make this right value smaller. That means when target equals nums, we want to keep moving our right, left. So we can simply do this. So when it equals or less, when target equals or less than nums mid, we make right move left. And in the end, after the while loop, our left boundary is our left variable. Let's give them a name. Let's call them low and high. And in the end, our left boundary low is left. You might wondering why low value is equals left, why not right? Let's look at the last iteration. In the last iteration, left equals right, and the value for mid is also equals left equals right. And if target value is in our input nums, that means this if condition definitely means target equals nums mid. And then, if that's the case, the right keep moving left. That's why this low value should be left, because the left didn't move at all. It still points at the last value. And let's look at the second one. Let's first reset the left value and right value. Let's also copy this whole thing. And in the end, our high is right. Here's something we need to change. So if the target value equals nums mid, what do? I think for this case, instead of moving right, we want to move in left. So if target value equals nums mid, we want the left value keep pushing right. That's how this mid value get bigger and reach its right. And in the end, we can simply return low and high. But we need to do another check if low value and high value actually make sense. So if low value is less or equal than high value, that means we actually find the element in the input array. Otherwise, we simply return -1 and -1. Let's try to submit. It passed. Let's look at the complexity here. For time, it's log n. For space, it's constant. And for this piece of code, some other people, they will put this binary search into a helper method, and then simply return its left boundary and right boundary. But for this, I will leave like this. If I didn't make this clear, feel free to rewatch this video. If you have any other questions, please leave a comment below. Thank you for watching.